Okay. So good morning. So today I'm going to cover two topics. You guys are going to be testing. So I will go over some reviews next session or maybe starting the next chapter. But today's going to focus on transformation of functions and analyzing function relationships. So transformations, there's all kinds of transformations. There's where we talk about our vertical stretches and shrinks. So how wide or how narrow a graph can be. We talk about it shifting up and down or left and right. So we're talking about the different directions of it and different reflections or whatever it might be. So let's kind of go through. I like to sometimes do stuff with examples. You guys got definitions, formulas on how to look at transformation in your notes. So let's kind of put together a bunch of different examples. When I look at these first four, they're all very similar, but different. So let's kind of look at this. So this first piece, so if I want to describe it, so this negative here out in front, this negative is always talking about a reflection. It's talking about a reflection, but there are two types of reflections. It could be a reflection across my x-axis or across the y. So if I'm across the x and I have some points up here, then if I reflect it across my x, it's going to like fold it's like if I fold my paper along that axis and it would end up here. If I'm going across my y-axis, then I would be folding my paper along my y-axis. And if I have some mark here, it would go across the y-axis to there. So that's when we talk about the reflection. Now, when this negative is out in front, if it's out in front, then we say it's a reflection across the x-axis. So if it was inside the square root, if it's inside the square root, then that would be across the y-axis. Or if I had some type of quadratic like y is equal to, and it was negative x plus 2 quantity squared, I don't know, plus 4, whatever it is. But see how the negative is inside the squared or inside the cube. If it's inside the radical, that's all going to be a reflection across your y-axis. So notice the differences there. So the next piece to these are this number here out in front. This 2 out in front, if it's greater than 1, if the number's out in front and it's greater than 1, we say it is a vertical stretch. And in this case, we say it's a stretch by 2. So the number out in front talks about something being vertical. If it's out in front, it's vertical. So if I look here, this is also going to be vertical because it's out in front. So we say that this is a vertical. Now it's not a stretch because it's less than 1. So if this value is less than 1, it's a vertical compression. So it's a vertical compression by 1/2. So notice the differences. They're both out in front. However, when we look at the value that is going to be inside the square root or inside the quadratic, what's being squared, when it's inside that, then that's going to be horizontal. So this is a horizontal. So now this one's tricky because we look here and you guys go, oh yeah, like it's greater than 1. So it has to be a stretch. No, it's the opposite. Because when we look at these, we're actually looking at the reciprocal. So when I say by a value, so how much is it going to be a horizontal, whatever it is, it would be by the reciprocal. So by 1/2, and that value is less than 1. So it's a vertical compression by a factor of 1/2. So it's actually going to be getting thinner. And then when we talk about this one, so this is a value of 1/2, but it's really going to be, so again, it's inside, so it's horizontal. And what's going to be by a factor, it's always the reciprocal. When we talk about horizontal, we take the reciprocal, so it's a 2. That number is greater than 1, so that's why it is a stretch. So kind of confusing because they're the opposite. Oops. Because they're the opposite. So it looks like they're the opposite. So be careful. My next two, these are kind of fun because this is just kind of putting everything together. So this was just to help you kind of compare some of the differences. When I look at number 5 and 6, it's really putting a lot of pieces together. So this number out in front, again, that's going to be our vertical because it's out in front. It is less than 1, so it's a vertical compression. We say by 1/3. This number that is inside here, it says +7. Now this is sometimes tricky for you guys, but this is actually going to be to the left 7. You guys think, well, but it's plus, right? So plus, the positive numbers are to the right. No. When we talk about this, remember that it's the formula is x minus, so it's x minus a -7, but the double negatives get written as a positive. So the value here is actually a -7. That's why it's to the left. And remember, it's grouped with your x's. So think the number grouped with your x's is the values that are going along the x-axis. So that's how I know it's left or right. Then it leaves this number out here as my y value. So it's a negative. So my y values are negative going down. So this would be down 4 units. So bringing all the different pieces together. And then my last one of these. So again, just a good little review, putting pieces together. When I look here and it's on the inside, so this value here, it's on the inside of what's being squared. So when it's on the inside, it's going to be horizontal. So when we talk about horizontal, remember we say it's going to be by that how much is it going to shrink or compress? It's always the reciprocal. So when it's horizontal, it's always the reciprocal. So since this number is less than 1, it is going to be a compression. And then when I look here, remember that this minus is part of your equation. It's always going to be minus on inside there. And so this is just a value of 2. So this is actually going to be to the right 2 units. Any questions on all those transformations? We kind of covered some type of piece from all of them. All righty. So let's go ahead and go. There's some examples. Here's an example of what they kind of give you guys. So those were kind of like almost like notes for that section. Here is an example that they gave you. So it says, consider the graphs f of x is equal to 1 over x and g of x is a times that 1 over x. Then it says, what happens to the graph if this value a, this number out in front, is negative and, so it's an and, greater than 1. So what if a is negative? So if a is going to be negative, we would have negative 1 over x. What would happen to that value? Well, remember, we said if the negative's out in front, if the negative is out in front, then we know it should be a reflection across the x-axis. So I look here, the graph is reflected across the x-axis. Check. So then what if a is going to be greater than 1? What if it's greater than 1? So what if it's a value such as 2 times my 1 over x? Well, if it's a value of 2 that's greater than 1, it's out in front, right? So if it's out in front, we should know that it's going to be some type of vertical. Since it's out in front, it's going to be some type of vertical. If it's going to be vertical and it's greater than 1, then we know it's going to be a stretch. And there we go. Well, so now if we know these two pieces, we could read through the rest and see the graph is compressed. We'll know if it's either going to be stretched or compressed. So it can't be both. So that can't be the case. The graph will shift a units to the right, a units to the left. No, if I had something like 1x like -2, something like that, that would be shifting left and right. And so you could go ahead and not worry about that. And if I had something at the end where I said like +2 out here, that would be my up and down. So little different pieces there. So looking at what did they give me, I'm reading through them. All righty. So that kind of covers that section of shifts, compressions. And they all call all of those different types of things are called transformations. So moving on, analyzing function relationships. Well, so we don't always like this section because there's a lot of words, right? And figuring out, well, what does it all mean? So I did pick out 2 word problems to look at. And so let's go ahead and look at this first one. It says, and I kind of sketched this so I didn't spend time doing it with you guys out already, but it says a plant is 2 inches tall. So we have a plant, it's going to be 2 inches tall to start off with. And again, sometimes when I read, I like to highlight things or underline things. In sunlight, the plant grows 1 inch each week. At the end of the 4th week, the plant is placed into a dark room for 2 weeks and stops growing. It is then returned to the sunlight and grows at the same rate for the next 3 weeks. Describe how you would go about sketching the graph of the relationship. Include key features about the graph in your description. So this was one of those questions kind of open-ended. It doesn't like, there's not like a, here's your answer and you select it. You actually had to like kind of write about it. And so let's kind of work through what does this graph look like? And these are some things your answer should include. So let's talk about how do we even get any of this information? So first thing is that when if we haven't had any weeks passed, I know my plant is 2 inches tall. So these are my number of weeks and my height. Number of weeks and height. So at the end of the 4th week, the plant is placed in the dark room. So for the first 4 weeks, it's going to grow 1 inch every week. So it's going to go week 1, it's going to grow 1 inch. Week 2, it's going to grow another inch. Week 3, it's going to grow another inch. Week 4, it's going to grow another inch. So this is all when we're in the sunlight, right? So you can see my graph going up here. Great, looks beautiful. Okay, but then after the 4 weeks, it's placed into a dark room and it doesn't grow. So after a week in the dark room, it's still the same height. And then another week, it's still the same height. So this is when we're in our dark room. So that's for 2 weeks. And then it's placed back in the sunlight for another 3 weeks. And when it's placed back in the sunlight, it continues to grow. So I'm going to grow another inch, it's going to grow another inch, and it's going to grow another inch. And you can see, so when we're back in the sunlight, it's going to grow. So what are some things that I can pull from this graph? Well, this very starting point right here, this point right here, that's my y-intercept, right? So that point for my y-intercept is going to be at 0, 2. That's one thing I can easily pull. What else can I pull? Well, I can see that it is increasing here. My graph is increasing because it's going up. This is what we would say is a constant because it's not going up or down, it's just staying level. And again, my graph would be increasing here. So how do I describe those increasing things, those lines where they're increasing? And so this was another piece of like being able to look at things and where is it constant, increasing or decreasing? So when I talk about how do I know if it's increasing versus decreasing, when I read a book, I read from left to right. Same thing looking at lines. I always want to go from left to right. So if I go from my left side to my right, I would have to be climbing up this hill to keep on going. So that's when I would be increasing. If I had something that went like this, then I would be climbing up this hill, but then I would have to come down this hill as I'm going from left to right. So just kind of a good little trick to help you read. So increasing, so I would say from this point, when we talk about increasing, we're talking about and constant, we're looking at our X values for increasing, decreasing, and constant. So from here, we're at when X is 0, and it goes increasing until my X is 4. So we say that it's increasing from 0 to 4. Here it'd be constant from my 4 to my 6. So from 4 to 6, it's constant. And then from here at 6 to my 9, it is increasing again. So increasing 0 to 4, increasing 6 to 9, constant. I can also point that it stops here. So after my 9 weeks, we don't have any information. And so here, this is my highest point. So I can say that this is my max. I could have also stated that this point here is my min. So there's more information that's not here that you could have stated. But just to give you an idea of where some of the information is, some of the information you should be looking for and grabbing from the graphs that they want you guys to be able to identify. So you're increasing, constant, decreasing, intercepts, maximum, minimums, things like that should be what you should be gathering from the graphs. All of your answers will have something to do with those relationships. So example 3 is multiple choice or select all. So you don't have to type it out and write your answers. So when I look at this one, example 3, they gave you the graph. If they don't give you a graph and they give you a function, put it into Desmos and look at the graph. You guys have calculators to be able to use and look at it. So for this one, it says the path of a basketball during a free throw can be modeled with the function shown where X is time. So important, X is time. So my X axis is representing my time. And it says that time in tenths of a second. Tenth of a second. And it says that since releasing the ball, and f of x represents the height in feet. So this is going to be our height in feet. So I like to label my axis. So I know, okay, when I look at these values here, I know what this is telling me. When I look at this point, this is saying that x value is 0. So at 0 time, the ball is at 6 feet. That's what this is telling me. So if I haven't even thrown, the ball is at 6 feet. So the person must be starting when they start to throw at that 6 feet mark. Okay, so it says, which statements are correct? The basketball reaches a maximum height of 7 feet. Well, this is a parabola. So this value right here, this vertex is going to be our maximum. If the parabola opens down, we have a max. If the parabola opened up, we'd have a minimum. Maximum, it's our highest point. So when I look here, it's talking about feet. It's talking about the height. That's going to be this value right here. So that is true. It has a max value of 7 feet. That's the highest that the ball goes. This one says that the basketball reaches a maximum height of 20 feet. Well, it can't be both of these. We already said it's going to be a max of 7. So we know this can't be the case. But where does this 20 come from? Why do they even say that? That's because there's this 20 here. But what does that 20 actually represent? That 20 is actually representing the time, tenths of a second. It's the time. So when the ball hits the ground, when it's at 0 feet, it took 20 tenths of a second. The height of the ball at time 0 is 9 feet. And we talked about this. If we're here at time 0, that height is actually at 6 feet. So this is wrong. So it's actually at 6 feet. So I look at the next one. It says the height of the ball at time 0 is 6 feet. Well, we just already found that out right above. So this is true. And then my last piece says that the graph is symmetric about the line x is equal to 5.5. So that's going to be this line right here. Well, yes, this is true. It's symmetric. How do I know that? Because remember, going through our vertex of a parabola, vertex of a parabola has a line of symmetry. So when we talk about this, sometimes you're asked to identify what is that line of symmetry or that axis of symmetry. So depending on how you guys were taught for this previous thing, just wording sometimes is different from textbook to textbook, but this is your line of symmetry. So if I fold my parabola in half at my vertex, it's always going to be so that the parabola ends up on itself. It's always going to be my line of symmetry. So yes, I have a line of symmetry here at x is equal to 5.5 because that's the value where my x is through my vertex. And so all 3 of those are correct answers. So these are all the examples I have for you guys today. If you have particular problems that you get stuck on as you're working, you can email them to me, or you could set up a meeting on my Zoom Calendly, whatever's easier for you guys in regards to reaching out to me, but I'm here to help you guys. Let me know if you need anything. Otherwise, you guys have a wonderful day. Do I have any questions?
No, ma'am, I don't have any questions.
All right. Well, you have a fabulous day.
You too, ma'am.
All right. Take care. Bye.
Until next time.
Yes, definitely.